breaking the wall of drought and water pollution. Kalina Fonseca, the Technical University of Cotopaxi, Ecuador.
I come from Ecuador, and I want to show you a typical landscape of the Andean region. Here we have the páramos. Those are important ecosystems because they provide irrigation water, job for local communities, and food for us. But here is the paradox. Large-scale agriculture depends on this resource, but it pollutes it. As a result, fertilizer, pesticides are impacting key crop production, such as potatoes. Potatoes are a key for the Andean cultures. You may say, why not to include irrigation water management? Probably in developed countries that is popular. So we have scientists, we have decision makers, and they can use this kind of fancy equipment to measure variables such as stress crop or water flow. So it could be a solution, right? But this is a problem for developing country. Could be expensive, and they are designed for specialists. And we have the wall with our local communities, which are usually excluded from these strategies. So our project, Open Science Water, okay. Could you turn the volume, please, a little? Yeah. Yeah. Open Science in Water, it is focused on irrigation systems. So we use open source equipment that has been designed by students and student researchers and professors. So we started with 3 pilot communities, but now we are crossing Ecuador. So now it is time to listen from our communities.
Bueno, con este equipo que sacó la Universidad Técnica de Cotopaxi, nosotros sabemos que cuando el agua está contaminada y cuando el agua no está contaminada.
En nuestros celulares podemos detectar en qué momento no podemos regar o en qué momento sí podemos regar el agua como riego en nuestros cultivos, en nuestros terrenos.
So, it has been a really long journey. We started in 2017 implementing strategies to improve the water quality. However, we learned that it was most important first the setup of water quality monitoring system. So our first challenge was to include or to engage, in this case, stakeholders, for example, decision makers. So now we are working not only with municipalities, we are also working with governmentals and NGOs. And here, about the surprises. You know, to work with the communities, it is challenging. So for us, we had to include first 3 communities because they weren't convinced in participating in this project. But now we have received more and more communities that want to enjoy to this project. So with this equipment, we can not only measure water quality parameters, but also we train them. First, to understand how is the water. Second, to know to teach them when they have to irrigate or not, and finally to know how to in a way to improve the water management together. Thank you.
So, do we have questions? Yes. Can we get? Go here to
great presentation. I'm just interested in the numbers of people you've empowered and the equipment that you've distributed.
Yeah, so we started with 3 communities, local communities. Usually they organize in irrigation boards. So each community has about 20 people at least. So first we work with 60 people, and now we have practically across Ecuador, they are looking for the solution.
Thank you so much. I'm curious, how was the reception of the people in the communities? Not only the ones that participated, but also the community, because it's a big community, very strong, as I know from Ecuador. But how was the reception there?
Yeah, in the beginning it was very difficult because in a way they know that the products that now, the water that they are using to irrigate the products, in a way they can be polluted, and they didn't want to show to everyone about this problem because of the trading, the market. So, but we started showing them the benefits to understand about the water quality, to improve the water, and then they also can go not only in Ecuador, but also the idea is to export the products to meet the quality.
Thanks. A really interesting project. I just wondered if you could just say again about how the technology is originated. So do the farmers and the landowners get involved with identifying the problem and developing the tech, or is it such a problem that there's no need for a discussion about it?
Yeah, okay, first, related to the technology. Okay, so if we want to buy this equipment in Ecuador, it's very expensive. If we buy here, it's totally different. So it was the first challenge. So in our university, with a group of engineers, professors, and teachers, they develop by themselves, and we test with products, like commercial products, and we got the same results. So because it's something easy, but something easy probably here in Europe, but then when you move to Latin America or in developing countries, it could be a challenge.
Thank you, Kalina, for taking care of water quality for agriculture. 2 questions. So the first one is, you are all using open source.
Yeah.
But still the equipment looks very complicated. So can you tell us what the difference between the commercial cost and the cost of the equipment that you're providing? That's 1. And 2 is, you detect polluted water. Then what happens with policymakers? What change have you been able to make?
Okay, so for example, this equipment, if we buy from Europe or United States, it costs about 5,000 euros, And the problem is the bureaucracy. It is not just to buy this. We need to wait at least 4-6 months. And then if we build by ourselves, it costs about 1,200 euros. So here actually is the electric engineer, is Paulina, is over there. Paulina, he is there. She's actually the brain of the project in a way. So first, and the second, this is a huge challenge in Ecuador, because first we don't have a monitoring system. So first we need to implement that. And then if we want to discuss about solution, the decision makers want to see what about the problem. So it was our first challenge, to show them with scientific evidence that we have this and we need that. So we are in the first steps. We are implementing now in Ecuador this monitoring system.
Do we have more questions from the jury? So, but that's audience. If we don't have any questions from the jury, maybe a question from the audience? I don't see where someone pointed. Yeah. It's behind. Okay.
Thank you. What kind of compounds are you measuring in the water, and where are currently the limitations? So what would you like to develop in the future?
Yeah, sure. Okay, first related to the sensors, we measure pH, that is basic for irrigation, electrical conductivity, dissolved oxygen, and I think I missed one, temperature for sure, and solid, something related to solids. So those are basic for irrigation. For sure, we have a lot of limitations, for example, related to heavy metals. So for now, we have been working with some of them, but we are still on our way.
Thank you. I think we don't have more time for questions, so thank you very much. Thank you. Go back. Take it.